Welcome back. So we were talking about how you can process the cover slips. So this is something very tricky because most of the cover slip suppliers, they will claim that a very good quality glass and all those kind of things. But over the years, what I have realized that whatsoever be the case, you need to do some sort of a treatment. You can do a plasma cleaning, you can do a acid cleaning. So plasma cleaning, you needed a plasma setup, but even before you do plasma cleaning, it is always a good idea, whenever you receive the box, get the batch number written somewhere so that you have a track in your register. And then the first thing you should do, you should put them in soap water, small amount of soap. Just I will leave it to your intelligence or to your judgment. In a small little soap solution, soak them. And if possible, if you can swirl it using a magnetic stirrer, that may be a better idea. That way the soap will kind of, will be all over the surface of the glass. Once you do the soap treatment, then you wash it. Maybe a soap treatment of 5-6 hours or maybe overnight if you feel like. That way, you reduce your, so you take a bunch of them, the whole box, so that you can use it over a period of time. The next thing is, it is a good idea to etch the surface a little bit. Etching could be done by putting it in a piranha solution, concentrated HNO3 and hydrogen fluoride, HF. These are the ones which kind of make the surface a little rough. And this roughness of the surface of a cover slip, starting from here or here, will be very helpful when we will be talking about absorbing the proteins. Now once you have etched the surface, so you just have to drain the water after washing, after soap wash, and in that put the piranha or the HF solution. Just be extremely careful because both of these are really, if it splash, you will become injured. So be very careful, take proper care, proper gloves, necessary mask, and then do these kind of things, okay? Because in a regular biology lab where you are not doing chemistry on regular basis, people are little, not very careful on these matters. So just be careful and try to do it very close to the sink so that, even if there's a splash, acid splash, you can immediately, put that exposed body part, and try not to have exposed body parts. So once you put the nitric acid or hydrogen fluoride into the system, you leave it. If you can swirl it, it's a good idea, but again be very careful. You leave it there for 6, 7, 8 hours, or maybe again overnight or a half a day. Then drain the acid or the hydrogen fluoride solution very carefully, very carefully. And be careful about draining it, because when you are draining these kind of solutions, you should have a setup, because you cannot drain such things through the sink. There has to be a jerry can or something where you can collect it, because draining such things in the water pipe can really pollute the surrounding water table if you are doing it in large scale, okay? So just be careful, follow these basic thumb rules. Then again wash it in water, in running water. And this cleaning is very critical. This cleaning has to be done very thoroughly. Put on the gloves, first of all wash several times, and then put on the gloves, and then slowly, allow it to really the water to, roll through all over the place so that the last trace of acid is kind of removed. Once you have done this, then the best idea is put 100% alcohol, drain the whole water, put 100% alcohol in it. So what all you did? So you did the etching, and after the etching, so this is the etching of the glass cover surfaces. Then what you do, you etched it. After etching, now you are washing with water, washing with water, a thorough rinsing, thorough washing with water, followed by, now you have the cover slips in a beaker like this. Now you pour 100% alcohol, and in this solution you just put a paraffin thing and you can store it. Generally I used to store them in 4 degrees centigrade, somewhere in the corner. Now suppose today you need 6 cover slips for your work. So the way I used to do it, this is from my experience I am telling you, this is how in most of the old school people used to do it. So take a Bunsen burner or a spirit lamp. I am drawing it with a spirit lamp. Okay. Now pull out say 1 cover slip on a using a forceps. Here you have the forceps, and here you have the cover slip, and you hold it very gently, and this do it very, very, very carefully because you may burn your hands, and just flame it. Do not touch the flame really, it's kind of you hold it here like this, and just you are doing a mild flaming. Okay, doing a mild flaming. Just with that mild flaming, once you do the flame, you will observe something very interesting. You may find there may be bit of a deposition of mild slight carbon. There may be slight very mild black. Don't get worried, that's actually good. That slight carbon, burnt carbon is actually good, because again this is coming from experience, this is not the textbooks are going to tell you. That mild carbon layer which is formed because of that flaming in the spirit lamp, and it is always good to do it in a spirit lamp. It works like kind of very neatly. Once you are doing everything inside the laminar flow hood, so you have to be again very cautious because there is air current which is moving. Be very careful. Okay, be very, very, very careful. Once you do the flaming, there will be a slight kind of blackening, and then you can place it in a sterile 15 mm dish. This is now all ready for any kind of coating or anything, and prefer that wherever you have that carbon coated side, try to keep that side on the top, so that on that side, so this is carbon coated surface. On that surface you are having, you expose that surface at the top to have the proteins or whatever extracellular matrix you want to deposit on top of it. Okay, all the ECM stuff you want to deposit on top of it. This is how it works. Now there are people who will tell you several things, and one more thing try to avoid with glass cover slips. This is the do not, I am just putting it, do not autoclave. Do not ever autoclave glass cover slips. Do not, because it changes the property because of the high pressure and that moisture. It changes the properties of the glass, and at times it changes its optical properties, that visualization becomes a problem and it changes things drastically. So please, please, please avoid autoclaving the glass cover slips. So once you have these glass cover slips ready, now you are good to go to coat them with different kind of proteins, what part of which we have talked about. You have laminin ornithine, actually rather ornithine laminin, because you put the ornithine first followed by laminin. You have collagen, you have polydilysine, which is a synthetic substrate. So these two are the natural, and this is the synthetic substrate. Now at this stage I will take a slight detour to talk about, suppose your lab doesn't get a reasonable supply of good quality collagen. There is a very easier way to isolate collagen, which has been followed years together by most of the cell culture lab. That is called rat tail methods, rat tail collagen. So the way it is being done is very interesting. So there are rats which are being sacrificed, right? So what you do, you just take the tail of the rat. So it will be something like this. Tail of the rat. Now you take a hemostat kind of things, okay? Clippers. So there are two kinds of like clippers, you attach the clippers. And then what you do is start to twist it in reverse direction. Okay. As you will twist it, you will realize from the rat tail you will get this white color threads which will be coming out. And they're reasonably thick, but and you start collecting those threads, something like this, white color threads. These threads are high quality collagen, okay? Then you have to dissolve it in other organic solvents. There are different organic solvents and there are different protocols which are given, and once you dissolve them, then you have to run it through a column to get the fraction you are asking for. And then of course you can do a HPLC purification or something depending on how pure you want it. But this is one of the simplest ways where you can obtain collagen if your lab does not have a supply or you are running out of it immediately you want. So you just go to your animal facility and ask them, are you sacrificing rats? Because everybody uses rats or mice or something. But mostly it's good to do with the rat because you get quite a good amount. So you just take one of them and it's something like this. So you have a click, so you have the tail like this. So you move one in this direction, the other one is the reverse direction. One, if it is one is going clockwise, the other one will go to reverse clockwise, so anti-clockwise, fine. So once you do like that, that's how these threads are going to come out. So there are specific protocols which are being followed, and if you go online you will find them. But this is how a rat tail collagen is being isolated, and this could be used. You can use this collagen to make gels, you can make 3D gels, and you can make thin layers depending on at what level you are diluting the solution. So this is one of the easiest and simplest way how you can obtain collagen. Now having said this, now let's go back and revisit what all surfaces we have talked about. Okay, so if you look at it, so now we have talked about laminin, so let's add the other word in that game, which is ornithine, and gelatin, which I haven't talked about, which is basically a mix of collagen along with partly with laminin, and it's kind of a mixture, okay? It's the same thing, but these are all natural sources. This is gelatin, at times could be get from calf skin, you can get fish skin, gelatin. There are several sources from where you can get the gelatin, but it is nothing but it's a complex collagen matrix. There is one more natural extracellular matrix which is very rarely used, which is called concanavalin A. Concanavalin A. Concanavalin A. Concanavalin A is a lectin. What is a lectin? Lectin. Lectin. Okay. So lectins are carbohydrate binding proteins. Okay. carbohydrate binding proteins. Suppose your cell surface has lot of carbohydrate or glycoproteins remaining there. There are cells which have those kind of, say for example, you have a cell like this which has lot of glycoproteins which are coming out. Glycoprotein means protein with a carbohydrate moiety. Okay. Suppose the red showing the carbohydrate part of the glycoprotein. Okay. Something like this. So these are glycoprotein. Now these glycoproteins will bind to, so the lectins which are present, a lectin can bind to a carbohydrate because lectin is a protein which could bind to the carbohydrate moiety. So what you essentially will have something like this. If this is the lectin in blue color, you will have the glycoprotein part or the carbohydrate part will bind to it. Something like this. So there are cells like photoreceptor cells, especially photoreceptors of fishes and other animals, whose structure is very interesting. So if you remember the structure of the photoreceptors, photoreceptors looks like this. There are two kinds of photoreceptors in our body, the rods and the cones. And they look like this. Okay. So these are the cones, they look like cones, whereas you have the rod photoreceptors here. These are the rods. Now, if you look at this structure, these are very specialized neuronal structures present in the eyes. So this is your cone and this is your rod, and your rhodopsin molecules are sitting here. For the rod, which I am showing in pink color, the rhodopsins are sitting here. Whereas for the cones, depending on which color they are indicating, the conopsin molecules or color identifiers are sitting here. Now, if you look at these cells, the interesting part of these kind of cells are they have a very extended structure like this, which is the sensory apparatus of these structures. Very, very extended. I mean, think of the length with respect to the rest of the cell body. Rest of the cell body is very small, right? If you just look, this is the only part which is, this is the attachment part, forget about it. This is only what is left there. Interestingly, we figured out that these cells, it is very difficult to attach them in substrate like poly-D lysine. Contrary to this, these adhere very nicely on concanavalin surface. Why is it so? So I will distribute this paper for you guys to read. Apparently, this surface out here, it has lot of glycoproteins out here. This red, I am showing the glycoproteins, and on that I am just showing the glyco entity or the carbohydrate entity. It's a glycoprotein. So now say for example you bring in a concanavalin in close proximity to this. So let's indicate the concanavalin with orange color. Orange color. So here is the concanavalin moiety. So there will be a very interesting adhesion with this concanavalin, because there will be an interaction between the concanavalin substrate along with the carbohydrate entity of it, and here is the protein part of it, and of course here is the cell membrane. So it's very interesting to note, cell type to cell type, you have to really work it out in depth, in detail, in minutest details, to figure out that which extracellular matrix will do good as compared to the other one. And this only comes via experiments. You really do not have any like in a magic wand, okay, I do this, it's going to work. It really never happens like that. Like this experiment took us quite a couple of years to figure out that, is the concanavalin maybe a better substrate, because none of these rod and cone cells, what at that time we are isolating these rod and cone cells from the fish retina, okay, which is easy, and I will kind of explain this one in the next class, how you get one such example of a primary culture. So isolating the PR stands for the photoreceptors, which are either rods or cones. So it took us a while to figure out how you can have a long-term rod and cone culture, and that's where we figure out you can have it if you have a substrate. So what we did is very interesting. We had this cover slips, and exactly the way we prepare the cover slips. So the cover slips were all coated with concanavalin, okay, and this is concanavalin. And we made a comparative study, concanavalin A versus poly D lysine. And we observed that most of the rods and cone cells prefer the concanavalin substrate. They do not at all adhere on poly D lysine. Absolutely zero adherence to poly D lysine substrate. That was a very stunning revelation for us while doing these kind of experiments on extracellular matrix. And I'm pretty sure there are many such undiscovered wealth which may open up a totally new dimension about cell culture. So I'll close in here with this, and next class will continue a little bit more on synthetic substrate and how these could be used for patterning and all other things. Okay, thank you.